All right, yo, what is up, everyone? Welcome to week 78 of Chill Kernel Hacking for Fun. What is going on my screen right now? This is the remnants of last week's debugging session, which I was doing a little bit after the stream ended. I'll explain that in a minute. Let me just kind of get settled. Yeah, today we're going to be continuing with the toolchain stuff that we've been working on for the last couple weeks. And the goal is to move over to LLVM for the toolchain. And I'm hopeful that we can get there today. All right. Announcement sent out in the Discord. Cool. Let's get some music going. Nice. Got Twitch going. Let me get my chats set up. What's up? Welcome to everyone joining the chat. What's up, Insta Headshot? Nice to see you. All right. All right, now let's see what is going on here. So last time, and there's way too many windows open here. Oh, all right, yeah, what is up, everyone? So last time we were working on getting rid of libgcc. Because that's part of the GNU toolchain. And we're trying to move over to Clang and LLVM. Yeah, that's what we did in this commit, build everything using CC runtime. So CC runtime is this replacement. I'm sort of curious why. Let's try test one. See the chat widget woke up yet. There we go. All right, nice. Yeah, so let me show you something. So I did some debugging, and I'll make a commit, fix elf loader issue. Oh, dang, but I was not checked out onto the branch. Let me undo that. Let me just see something. Let me just let's just see what state we're in. We have these crazy warnings, but do we boot? No. Okay. Well, that's interesting. I could have sworn I was in a booting state. Moving from blah. What commit is this again? Fix. It's just the BD. Wait, so. Sorry, just a little bit confused about the state I left things in. Oh wait, okay, so yeah, no, I think I understand. I'll explain more in a little bit, but super high level overview is there is a bug in the elf loader. And moving over to CC runtime exposed a bug. Exposed that bug. That bug existed, but it previously wasn't triggered by the elf files that we had in the OS. But now with the new CC runtime change, it affects how these elf files get compiled, and the new something is different about these elf files, and it triggers the bug. And as a result, I fixed the bug, which I can explain. I also added some assertions, mostly just one assertion, I guess, to possibly help catch this in the future. But then I disabled the fix in order to see the assertion fail. So let me re-enable the fix, which is right here. So we need to do this instead of this. Then we need to do this instead of this. But that still crashed for some reason. Okay, that's interesting. I guess we'll do some debugging then. Yo, what's up, Della Vidova? Thanks for joining. I just like want to really make sure. Clean build. The assertion is failing. Let me just try one more thing. Let's use it LD. So we did get rid of the stabs stuff. Could you explain what you're coding or what it is? I keep seeing you run QEMU. Yeah, this is a custom operating system. It's called JOS, J-O-S. It's from MIT, and I just use it for kind of playing around, learning a bit how operating systems work, and QEMU. And we run the operating system in a virtual machine using QEMU. So that's what you're seeing. And I'm wondering, yeah, so okay, I might just focus silently for a little bit while I try to figure out what's going on here. Okay, so because let's was pretty confident I had this fix. But this assertion is still failing. Which makes me a bit suspicious. Yo, what's up, Ismail? Nice to see you. Thank you. Same back to you. Hope you're doing well. I am debugging something. It's one of those situations where I was pretty sure I had a fix. I did a bit of debugging after this last week's stream ended. Pretty sure I had a fix, and it's not working now that I'm running things again. So I guess we'll kind of have to get back into it. So let's just see. So where to even begin? So right, high level goal, let's use CC runtime instead of libgcc. Let me just, I'm just going to, temp elf fix 1, and I'll just fix 2. So just to kind of get everything committed and on the branch, let's just walk it through one sec. So here's the commit where we add CC runtime to the build system, but we're not actually using it yet. So in this commit, I would fully expect things to work. Yes, things are fully working in this commit. Then we can observe that in the next commit, build everything using CC runtime. Let's check out here. Let's do the same thing. Clean build. Things do not work. That's where this is where the crash starts to happen. It is 27th. I have some slight notes about this. So this is where the crash starts to happen, okay? And right. And then basically not too much else happens. We then do this like trivial commit to rename this variable in the makefile. Then last week we started to try to use the LLVM toolchain, but then kind of ran into this bug, ran into this other thing where LLVM objcopy wasn't working somehow. And so I kind of halted that progress. So I didn't engage any of that work. I just kind of kept it as a temporary kind of thing. But the thing that I did change is this tiny little patch just to slightly express the path to Clang differently. Not really a substantial change. And so I already have an understanding of the bug. It's actually related to the elf loader. And I guess what should I do now? I guess I will so in this commit, all I did was I added a bunch of print statements. I added an assertion and just some more print statements. And then I actually do have a bit of code here, but it's not really used. I just add these two variables that don't get used yet. And I think I was just testing to observe the assertion fail. And then in this commit here, I'm just kind of undoing this and I'm engaging the actual. So what about that end variable? That's used here, right? Okay, so let's just debug it. Just kind of go from first principles. Hey, what's up, Icron? Nice to see you again. Yeah, going all right. Got some problems to work through. I mean, Clang is not the issue here. I mean, the problems are my issues. But yeah, no, we're going through some interesting stuff. Let's just check back all the way back out to the Clang branch. Okay, yeah, so here's the problem. And so I already kind of know a little bit about the issue. Oh. Oops. I think it's does this look right? File size, FEE. Yeah. Oh, what's up? What's up, Mode77? What's up, Nomadic001? Hey, I'm trying to do a better job of checking and being aware of the Twitch chat also. Yeah, I stream on YouTube also. Yeah, but I'm trying to explore what Twitch is like too. Thanks for joining. Okay, so let me just make some room. Assertion failed. Space available for data greater than equal to file size. So what is that all about? So first off, the code that's running here is it's this. So the kernel boots up, it does a lot of initialization, and at some point it's ready to start creating the first user space processes. And the first one is the file system server. And that's triggering this bug that we have. And the bug is in load icode, which is the function that loads a user space binary. And there's just kind of a basic error here. What's up, Afnan? Thank you for the test too. All good, all good. Just lost the streak. No, I think you still are pretty high up. You're still on the leaderboard, I think. So let's use that top command. Yeah, you're still 5 on the leaderboard, so you still got a solid place. Okay, so how does this work? So basically, we're loading the executable, and we are loading every load segment. Those are these things. There's 2 load segments. Yeah, Ismail is clearly stacked on the leaderboard. Absolutely. This is interesting. I'm just going to quickly try this. I'm going to revert one commit. I have this one commit that removes this section from the user linker script. And I am just slightly curious how things behave if I do that. Still fails. That's good to see. The one thing I was just surprised at is I was actually kind of expecting there to be 3 load segments, because that's what I was debugging last time. But that first one, this first very, very small load segment, it just comes from this weird stab info section. But that's, so as I just tested, that's not really relevant to the crash. It crashes anyway, so I'm going to get rid of that commit just to simplify things. Okay, so nice and simple. We have 2 load segments. And it's time to process the first one. So we're just going to process them one by one. And I'm just printing out some information here about it. PH stands for program header, which is also the same thing as which refers to the current load segment, and so we can access it. And so I'm just printing out some basic info about this load segment. We can kind of confirm it against readelf. And so file size 7FEE, destination vAddr 8020 right here, offset 1020. So that looks correct. So now what the code needs to do is it needs to take the mem size, and we need to allocate enough memory in the process to fit this load segment. So let's just walk through it. That's what we try to do here. Region alloc, we're allocating memory in the process. And this is where the bug was. So mem size is 7FEE. And so what we need to do is we need to align and pad the allocation. So region alloc just handles all of that internally and returns a mapped length for how much memory it mapped for us. And this number can be bigger than mem size in some cases. And so I'm printing that out here. So mapped length is 9,000. And the reason it's 9,000 is because V adder, right? It's because we have this 20 offset. And so the segment is 7FEE long. That's like the actual data. It's this buffer of data. And it needs to go at offset, but it needs to start at offset 20 into this page. So that means we are going to slightly overflow into this, into the next page. And so that's going to get rounded up to 9,000, I think. So it's basically hex FEE plus hex 20, right? If we just look at how big that is, that's that. And so we slightly exceed that. And then that means the region alloc is going to round this up another page boundary. Sorry if I'm sorry if this is very hard to understand. I could draw it out, but I'm just going to try to move a bit faster this stream just to try to really knock this thing out. So yes, that seems correct. And then ignoring, okay, so dest v adder rounded down. This is not used until later. End pointer. Also not used until later. So for the purposes of copying this data in there, we take, so basically region alloc I'm also just noticing one thing that's kind of interesting. Right, so the question is what address space are we loaded in right now? And actually, we load into the process's address space. We actually do that. What's up, Michal? Yes, looking at this kind of crash from last time, which was happening in this mem copy. It was both. It was partially written by them, partially by me, and the code that's buggy is my code. And the reason, and just simply the bug condition was never triggered. Oh, I just like jumped somewhere. The bug condition was just never triggered until like just now, handling the binaries that are produced with CC runtime, because the binary gets compiled slightly differently with CC runtime than with libgcc, and that's enough to trigger this difference. Okay, and so basically the code was crashing here. So what does this code even, what does this line even do? So we're mem copying, and we're mem copying into dest vadder, which is directly the address we get from the program header. So we're mem copying directly at 8020. And the data source that we're copying, the data that we're going to copy into dest vadder begins at binary plus program header p offset. So it's binary is the pointer to the start of like the elf file in memory, and then p offset is the offset into the file at which the data for this segment exists. And so we're binary plus p offset to get a pointer to the actual data. And then lastly, we are copying p file size bytes from this point into that space. And so what I was basically trying to confirm that before we actually do this mem copy, I was trying to come up with an assertion that we could make that should help make sure that things are in a good state before we do this mem copy. And here's what I came up with. I came up with mapped len. Maybe drawing this out would be the most helpful thing to do. Okay, let's say each of these is like one page. And so this is going to be hex 8000. Something like this. It's 8020, right? And so 8020 is going to be like right here, except the other way around, but it's very close to here. And we don't actually need an arrow here. Let me just take a look at this again. So we have mapped length. That's the amount of data that we got back from the allocation. And so anything within this region should be okay to write to. And then what I'm doing is I'm taking mapped len minus program header offset, because we're only going to start writing at wait, is it or is actually wait, that's like not quite correct actually. I think I even ph offset is not, we want this offset, I think. Because we get this allocation of memory, and we're going to start copying not at the start of it, but at some point kind of into the allocation. So actually not that that whole allocation is not actually available to us. The real valid space that the memcopy can write to is, I'm just gonna make a int offset equals, it's actually dest vadder and enter T. So it's the mask within the page. I think I'm getting that right. Offset. I think that was the issue. P offset is the offset into the binary, which is not the right offset to be using here. But I just wanted the offset, this hex 20 thing. That's the thing I wanted to check. Because we get this allocation, but we're going to start writing it into it, starting from hex 20 into this buffer. And so that reduces the actual space that is eligible for being written to. And I just want to confirm that the amount we're actually going to copy, file size, is less than or equal to that ultimate end amount of space that is available for being written to. So let's just try this. Yeah, sorry, this is kind of a really like super hyper detailed thing. And I'm just kind of hand-wavingly explaining it. But I think that worked. Because the OS booted. Whew, okay. Always a bit of a panic. So I guess when I was just like wrote that assertion kind of wrong. Yes, so now this is in more of a, the assertion is actually more correct. Just to like quickly try to even draw it out. So maybe, so let's just say this, let's just say here is the mem size, right? This block is the mem size that the elf binary is telling us that we need. In this case, the file size is exactly the same, but it can actually be less in certain cases when there's data that should be 0 initialized at runtime. Rather than carrying all those zeros in the file itself, we just don't store them, and we just kind of represent this difference in the binary, and then the loader just needs to know to zero out this range at the end. And that's where all these 0 initialized variables go. So we have the mem size. In this case, the file size is equal. So then we go over to the memory allocator, and we say, hey, allocator, we have this mem size that we need. Please give us some memory for this. The allocator is like, okay. And it gives us this chunk, which is actually more than we need, but that's fine. And it does this because it needs to page align the allocation. And so it gives us this amount of memory. And so then we go to, and then we go to the elf binary, and we look at the vadder field. And this is basically going to point, it is going to have an offset that's going to point slightly, slightly at the start. So it's not, so it could be at the start, but in this case, we're actually not. We're sort of like here. And so the consequence is that file size is going to get copied starting from here, basically. And so here in this example, we can see that it totally fits because the memory allocator gave us a ton of space and file size just fits nicely in there. But we want to check, what if the memory allocator had a bug and it actually gave us this much space? Like way not enough for example, and we still are writing at some offset. In this case, file size is going to overflow that region. It's going to go past it, right? And so the point of the assertion is to compute what is the space between here and here. That's the space that file size is going to try to fit into. And that's exactly what I'm computing here. It's mapped len, which is this entire length, minus offset, which is from here to here. And that produces this box, which is like the home where file size is going to go. And the assertion is that this box, this length, needs to be at least as big as file size. And that's what this is. Space available for file data must be greater than or equal to file size. Okay, enough about that. Let's try to move on. I don't think so. I mean, maybe, but I don't think so. I think there would still be like, you still might just get a panic or something like this in the best case, but I don't think this is the kind of thing that Rust could just compile time like check for you. But interesting question. All right, let's just try to wrap this up. So this is what's the name for this variable? It's offset file data write offset into page. Maybe write offset, I don't know, doesn't really matter. Write offset. Okay, cool. So now this fixes there, that gets amended into here, that gets squashed into this gets renamed into load or fix region alloc elf loader bug. And we can even clean this up so we don't need this comment. Oh, wait, here. Don't need this comment, and we don't need this. So I will just drop these from the original commit. So now those are gone. Actually, yeah, we don't really need these printfs either. Or actually, wait a second. I kind of want to do this in fork with all this dragging and dropping. Why did that move away? Hello? Okay, and what do we actually need here? We don't need these, don't need this, don't need these. So this is actually our commit. And it has, I just had a bit of just a simple mistake also when computing the actual range to allocate. So the total bytes needed, because the virtual address can be unaligned. And so I round down the virtual address to the next lowest page. And then I rounded. So then I add length to that Then I add length to the virtual address where it's actually going to be written to get that upper bound, and then need to round that up to the next page size. And then the total bytes is the difference between that rounded up thing and the rounded down VA rounded base from earlier, which is like the actual maximum range. And I just wasn't doing that correctly. So now we just have all these prints, which I don't think we need. I'll maybe just stash them. Loader prints. Whew. All right. Let's grab a 20-second break. Be right back. All right. So this is cool. That was sort of a weirdly detailed thing to like jump right into. Oops. At the start of the stream, but so now we have the OS working with CC runtime, which is that libgcc replacement. What is that tool you use to debug? If you're talking about this one, this is readelf, which is my go-to like bin utils tool for looking at binaries. I use it all the time. This one, it's readelf. Yeah, it kind of does, like, the bin utils programs have certain overlaps in functionality. Like with readelf, you can do a lot of things. Like you can look at symbols in readelf, like objjump, or what is objjump? Lets you disassemble. So readelf does not disassemble, but you can look at symbols in readelf. You can look at the elf header. You can look at the sections, you can look at the segments, and that's probably like 95% of my bin utils usage is just readelf. Yes, okay, sweet. So with all of that done, yeah, it's not like that complicated. It's just a really good tool to know about. Okay, so now we can try to move on with the rest of this whole toolchain thing. And so if I recall correctly, we had a bit of luck. Like we were using LLVM AS and AR, for example. So, but with this change, I'm just swapping in to use LLVM AS and AR instead. I still don't love that we get all these warnings. And I sort of thought that we got rid of these when we got rid of the stabs sections, but for some reason I'm not sure about that. So but it built and runs, so that's solid. So I'm just going to okay, so that's working. What else? opt dump. I think opt dump was a fairly easy one. I think that mostly affects just the build process, because in the build we now look at that. That output was way cleaner actually. It didn't have all these warnings. So I think switching to LLVM opt dump somehow fixed that, or doesn't print those warnings, or handles it better or something. So like this should totally still work, but yep. Okay, so opt dump, another easy one. We'll commit that. I'm just gonna amend this into here. LLVM working. Okay, making progress. Let's try nm. So get rid of nm here, swap in nm. nm is also one of those mysterious programs which I don't really use. It also lists symbols, so it's like sort of a duplicated functionality from readelf. Objdump also does this. nm like also lists symbols, but there's probably certain things it uniquely does. I don't really ever use it, but anyway, it did not impact build, so that's sweet. So now we're kind of getting into those tricky ones, LD and objcopy. So let's try objcopy first. I have this comment saying that LLVM prefix. I have this comment saying that it was breaking things. But I wonder, I think that might have been due to that weird stabs issue. Okay. Okay, wait, but no, I just didn't name it correctly. Okay. I think now that I got, okay, no, the problem is still there. Something is strange still about LLVM objcopy. Okay. Okay, let's so we're gonna not use that for now. Quick, just check that thing's still build. And I guess let's try LD or LLD. Okay, now we're gonna not use LD, and we are going to use LLD, which is the LLVM linker, which is called ld.lld. Make clean make. Does this compile /link? Would be nice. Okay, it builds. Ooh, wow. Dang. Ouch. I don't know what happened, but that is crazy. Wow. It is crashing. How is it crashing? It's running. User fault. Yeah, I should really improve some of these error messages. But okay, yeah, so this is roughly where I sort of thought we would land. A lot of these things were pretty straightforward to port over. LD and objcopy seem to be the outliers, which is not super fun. So we have two options. Which one should we look into? This LD one seems kind of hardcore. I might just go with the objcopy one to start off and see if we can look a bit more deeply into it. It's interesting that it links, but it produces runtime problems. Yeah, a bit spooky. Okay. So, objcopy, what is going on here? What are we even seeing? We are seeing some log lines. Obj user hello, no such file directory. So something failed. Something did not create the hello. What's up, Anand? Did you go and throw element documentation? No, I did not really read anything about that. That, yeah, could be an option. I was sort of just hoping it would work out of the box without having to read too much, but we might need to do that. So let's just focus on this objcopy thing for the moment. And in usual style, I'll take a million screenshots to capture what I'm seeing. So we see some issues processing the hello program. And so then here's the relevant code that yeah. So this code, so this is all connected to hello.c. Hello.c is a super basic user space program that just prints out some text and basic info. And should be ob user hello.o. Yes, so let's just, good idea. Let's just peep that user hello.o. Indeed, we have, yeah, we can see that that worked. Hello.o. So now we're going next up, and now we link it. With this command line, and apparently it's .debug for some reason. ULD flags just means pass the linker, the user space linker script. LD flags is just passing -m elf i386. No standard lib. For some reason, that's a linker argument. You know, it'd be kind of funny if you need to use both. Like, what if I change? I only tried tweaking one at a time. What if using both at the same time fixes the problem? I don't really expect that would be what happens, but okay. So then we This thing stands for hello, or no, it's obj-user hello, which is just this thing, I think. And we just link entry.o with our hello.o, and we pass it this libdir for some reason. And I'm just going to ask the AI quickly, what is what does capital L do with GNU LD? And I don't know, what's the best model 4.1? Okay, so when you pass in dash lowercase l blah blah blah, it is going to look in dash uppercase L for these libraries. Okay. And apparently we use that here with like dash L lwip dash L JOS for some of these libraries. And lib jos.a, lib lwip, stuff like that is right here. So that's what it's going to find. Okay. And then we pass this, our cc runtime.o object, which should be a totally valid way to pass this. So we need to link in that with with our program, so that okay, I think this is just a simple, this sort of just smells like a command line error. So you see runtime, technically it is just an object file that we are building in with our OS, but conceptually it is kind of like a static library, but we're not even packaging it like that right now. We're just literally taking this like cc runtime.c file that is just like this one single C file. We just compile it into an O file, and we just link that with like other things. Very simple. Yeah. I think this is just like a really dumb command line arguments issue where LLVM objcopy is like incompatible, has incompatible command line arguments. So this might be a good opportunity to ask AI to just like help. Agent. So formerly we were using GNU objcopy. On this line. We are now using LLVM objcopy and get this error. Is this a simple CLI incompatibility? I will just, yeah, what's up, Useless? Nice to see you. Okay, so yeah, so this is actually not a super interesting problem. It's just simply an incompatibility. So what is it? Add GNU expects the argument to be just the base name. Does not create the output file if it doesn't already exist. To fix this, you should first copy to blah before or with strip debug. Okay, it sounds like this. How do I I'm just going to wait, it actually sounds like this is really easy. So if I just use strip debug, does that fix it? No. Okay, so did I do this right? I think that might have been a hallucination. Or maybe you need to say, it's saying you need to possibly pass the whole file. So that would just be this with no base name. That might be working. I think that worked. Let's just do a clean build just to make sure. I think that is working. So this was a completely uninteresting issue. It's just like the command line arguments were not compatible. And okay, silly issue, but whatever. So now now we are using objcopy, and we can remove this comment. Objcopy fix. All right, so where does that leave us at? Except this thing is still here, so I mean, all of this is going to get squashed anyway. I'm just trying to preserve these fine-grained steps. Okay, so that leaves basically that like sicko mode hardcore LD issue with LLD. Unless that magically will disappear now that we fixed the objcopy thing. Kind of unlikely. Let's try. Okay, make key move. All right, sicko mode crash happening. Okay, so what are we seeing here? Seeing something like this. User fault, blah, blah, blah. That's not normal, is it? We don't usually see make clean, make We don't usually see that user fault line, do we? This is a normal boot sequence. We'll just compare these left and right. So FS can do IO, blah, blah, blah. And then we get the user fault. Maybe this would be a good time to also ask AI. Actually, all right, 20-second break, be right back. All right, yo, Kadar Codes was also digitalized. What is up? What is up? Hope you're doing well. So I think this is a good time to probably just ask the AI if there's any problems with LLD. I also want to swap out GNU LD for LVM LLD in my OS. There any gotchas or incompatibilities to be aware of, or is it a drop-in replacement? I'm actually wondering about linker scripts. Are the linker scripts compatible? Because we don't actually pass that many linker arguments, do we? No stdlib. I'll just ask. Like, before we just dive into that, like, really hardcore debugging, we might be able to save some time by just thinking a little bit about this. Okay. This was not really that helpful. I wonder though, what, because the kernel, the kernel does boot. It only starts to fail in user space. User fault. Things are like null pointer dereferencing. So much text. Yeah, our build system's kind of noisy right now. User fault, blah. Free env. User fault, trap frame, free env. So it basically means the environment got killed. And it just seems new environment. It sort of seems like things are just crashing and dying, but user default VA. Some weird addresses going on. What's up with this strange EEBFEFFC address? It's like kind of a sus address. I'm not really sure. This is like kind of strange. It's a null pointer dereference here. But it's probably just some core issue that's the source of all this stuff. I guess FS can do IO. Where is that printed? Let's just anchor ourselves in the code and just see serve.c. Okay, umain. Sort of confused at even what binaries we're talking about right now. So serve.o, FSO files. This is used when creating the FS binary, which is the file system server. And here's where we use LLD, but nothing really stands out. So anyway, so fs.c is, so fs.c is this function with a lot of just these file system routines, right? And there's only one of them, yeah. Serve, so this is where the main is, I guess. It's been a while since I looked at this code. Serve is where, and serve init. Serve open. FS init. Serve. So let's just debug this and just see how far we get. Make kimu gdb, make gdb. And we're gonna be, where do we break? How does it work again? Debugging user space is always a bit tricky. But this is the, no, wait, this load icode. If this is running. Because these lines come from icode, which is like the init process. And it's able to run and do things. I'm just thinking about the best way to actually set a breakpoint. What's up, Krishna? Nice to see you. Like the option, I can't, so I can't just do like break umain, because at this like stage of the debugger, it doesn't know about any of the user space binaries, so it doesn't have any of those symbols loaded. Although, so I should have learned how to do this, but if I just do file, do I want to change the file? Yes. Yes. So now I can do break umain. I'm not sure if this will work, but let's kind of see. That actually did seem to work. So that actually was not as hard as I thought. We just need to load in the FS binary, which loads the symbols, and then once we have the symbols, then we can say stuff like umain and these like actual names for addresses. Otherwise, we need to use these like hard-coded addresses. I don't think it's not anything crazy like a file system incompatibility. It's like yeah, no, it's just got to be some kind of linkers, something. I mean, it's actually very interesting. I'm curious what it is, but I have the suspicion that it's just like a simple thing that's going wrong, and maybe it's something in the linker script that is being treated differently. I mean, even just talking about that is interesting. Maybe if we just look at the linker script, I don't know. If there's anything that could look like it's very GNU only or something like this, but let's just see how far this gets. So we observed in the log that we get this line, and then at some point later it has this user fault blah 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 thing. So let's just step. So it did mention discard. It did mention discard. I would be a little bit surprised if oh wait, did it okay, no. Can cause issues. Certain symbol assignments. I wonder. It's maybe possible. I sort of doubt it, but I might be wrong. So serve init. Let's see next. So that worked. Serve init worked. Fs init. That is the thing that did not work. What's up, Octavio? I see you. So that is interesting. Fs init was the thing that really just caused things to break. And what happens in fs init? Let's just try that again. Yes, break fs init. Okay, we're in fs init. And that even did it. IDE probe disk 1. No, wait, really? Is that the thing that... Let's go even deeper. How do I, just want to symbol file. Huh. I'm just going to pre-configure my GDB to automatically kind of set up for me. So, oops. Did that not work? Why did that not work? Is it symbol file? Okay, I don't know. All right, IDE probe disk. So Byte, are MacBooks good for software engineering? Yeah, I would say so. I know a lot of developers that use MacBooks for software engineering. They're pretty popular, but not the only option. IDE probe disk step. Let's really. IDE weight 0. So this is all using I/O ports. Oh, okay, so this is like kind of interesting. I don't know this code well at all, but it seems like we are crashing on this printf line. Macs run a special form of Linux, so I assume they're good. Isn't that true, digitalized? I mean, yeah. I mean, it's definitely it's like some kind of Unix, but I thought it was more like BSD or something like this, like some combination of BSD and like Mach or whatever that thing is called. John says witchcraft. This is crazy. So we tried to like print something out, and then it's things sort of just like explode a little bit. User fault VA. I need to refresh. User fault VA. This this line comes from the users. It's like when we're about to invoke the user page fault handler, I think. It's right here. Wait a sec. Oh. This is when things fail. Interesting. So this code runs when a page fault happens from user space. Yeah, this is, I mean, what is going on? It's what kind of linker issue could possibly be causing this? Hey Brian, what's the thing on the right and the left? Are those all the same program? So if on the right I have my Git client, on the left I have my like compiling and debugging command lines and stuff like that. Yep. So we're getting into the weeds right now. What? Like, it's very tempting to just go like super deep into the weeds, but I'm trying to also kind of remember that the reason why we're doing this is because we changed the linker. And so maybe there are other ways to shortcut this debugging rather than going like 100% like balls to the wall, like really in the debugger, like looking at the page faults, stuff like this. I wonder, for example, one thing we could try is to examine the binaries that are produced, maybe. Again, like going back to the readelf discussion, at the end of the day, we're seeing a problem in user space. Like the kernel itself seemed to work fine with LLD. The problem was it's like in user space. User space even seems to be able to like kind of run a bit, but then strangely it starts to crash, and it seemed to be in response to the printf. I mean, we could continue to go deeper like I've been doing. We could step into the cprintf, but what does that actually do? Cprintf is just printf.c. cprintf put char, it just wraps put char and c put char, and eventually we're going to hit a system call. Right, I think that's here. Yeah, eventually we hit sys c puts. Is that our first system call? No way. Or serve. It might be some no, but we were doing printfs earlier. FS can do IO, so clearly we were able to do system calls. So there is something weirdly unique about what was happening here. Yeah. Yep. Just catching up on the chat. Crazy the linker would cause this. I had no idea. Me neither. I mean, swapping out your tool chain, it's kind of a fundamental part of the project, so I'm not completely surprised. Like, it does involve quite some low-level stuff. All right, I'm going to slightly pause this and head in a bit of a different direction and just see where that takes us. What I'm going to do is just, I'm going to copy copy what is it? It's fs.fs, right? Copy that fs.lld, fs-lld. So I'm going to just copy this binary out, and then I'm going to go over here, and we're going to switch back to GNU LD briefly. And so basically we were going down one path of the debugging, which is like the really hardcore, deep into the debugging, like debugger, like all that stuff, which is kind of like effort intensive. And it is like, it's one tool, but it's a very intense tool to get the job done. And there might be an easier way. And so what I've just basically done is, so now we're going to get a copy of the FS program with the GNU LD link here. And I just want to see what kinds of differences are we looking at with these binaries? And the way I'll do that is I just want to diff the readelf outputs of them. So it's not like, I'm only considering this because it's not that hard to do. So this is my clue you in on my secret way I diff stuff. So I'm gonna awfs dot GNU LD. Right. Okay. So just to explain this command line, because I learned about this kind of thing way too late. My goal is to run readelf on 2 programs and then diff the outputs. And what I'm using is this thing called process substitution to do that all in one command line. Because sdiff is my kind of preferred, like a good diffing program, but you need to pass it 2 files to diff. And I don't want to pipe the output of readelf to like a file and then do that twice and then diff them. So with process substitution, I can pipe the stood out of this command into this psub thing, which allows me to use that as a file. So that's just sort of what I'm doing. So now let's just take a look, maybe. Are you an engineer student, Mark? Yeah, no, I have a job as a software engineer, yeah. Was a student formerly, but not a student at the moment. So now we can like just kind of look at the 2 readelf outputs, and we can look at these lines and see what's different. And I just need to remember which. So LLD, maybe let's make it GNU LD is on the left. LLD is on the right. Readelf is giving quite a bit of warnings. So we've pretty much fully expect all of these lines to be different. This is end trap frame. Ooh, now that is interesting. So check this out. It seems like, so this left arrow means there's something that's only on one side, basically. Although, actually, I don't know if the diffing is that good, but, oh wait, actually, never mind. It is in both, so I just, I was sort of thinking like, oh wait a sec, why, is it possible that this function like only exists in the GNU version, but it disappeared in the other version? That's not true. It is just up here. But what's weird is that actually there is one thing missing, it seems. Because this like the whole thing is like one line longer. And I don't know what that is. We could try to find out. So any quick differences we could try to see? Okay, so there's 4 program headers. It's always kind of interesting to look at the program headers, actually. Those are kind of revealing about, just sort of like high-level overview of like what's going on with the program. And I think I know why. Check this out. So text and row data. Okay, 20 seconds, be right back. So check it out. Text, this is actually pretty different. Text and row data were formerly in the same segment. And now they're not. Which sort of makes it seem like the linker script is being ignored or something. What's up, Nicolos? Yeah, writing my own kernel, sort of. I didn't write all of the code. It's called JOS. It's this OS from MIT. But yeah, it's a custom kernel. It's in C. Yep. Yeah, so let's this is interesting. This is definitely a difference, and that's why we have an additional load segment. It seems like text is it gets an read executable segment, RO data gets its own read only segment, and data BSS get a read write segment. Previously, we were putting text and row data into a read executable segment. So technically the row data was executable, which is like kind of weird. Here is where we define the sections. So I mean, so that is an interesting behavior change. It's also interesting that there's actually quite a lot that is the same between the sections. Like text seems the same, data BSS, blah, 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 blah. These are all the same. Syntab, string tab. And what's up with the row data? Some flags seem different. Interesting. I wonder. Okay. So yeah, like what's the missing thing? There are probably some different ways to find that out. Call it RT abort. Wait, what? Okay, I'm surprised why. I'm a bit surprised to see compiler RT mentioned here. This side should be the GNU side. I'm just going to, I'm just going to ask the AI what is the missing symbol. Here's two read elf outputs. The left one has one more symbol than the right. What's the missing symbol on the right? So it's hard to tell. I mean, if I really knew my Unix tools, I would just like whip out some command line. Wait, no, that's not right. It's there on the right. Is the local file symbol for entry.o? Really? Let's verify this. Entry.o? I think it is right. Weird. Okay, so entry.o. There's only one reference to entry.o, and it's only on the left. But what? I don't think that's that. I don't think that is that important. Our file. What is the importance of file symbols? They're just a metadata thing, so I don't think that is very important, really. Can you explain the difference in the diff for the row data section, especially the AMS flags? Is marked as containing mergeable null terminated strings, while the left is just... I don't think this matters. The interesting... So basically I haven't seen anything too crazy. Probably the most interesting thing is this segment difference, in that we have an additional load segment. And just to back to load iCode, actually I think we don't really even implement the permissions correctly. Fix me. Respect the flags and alignment of program headers. Currently flags and alignment is ignored. Ouch. But they're all page aligned, so yeah, hopefully, I mean, maybe I could even add an assert, something like ph align equals hex 1000. I don't know. Just curious, what does that do? Make clean. Okay, so things worked. This is, I'm still using the GNU LD, so it's totally expected that this would work, but things did not crash. So now let's go back to LLD. A little bit, it takes, compile times are kind of getting a little bit long. So yeah, so things are crashing in the same way, but our alignment assert is holding steady. From IP blah blah blah. So this is interesting. Maybe let's take a look at what's going on here. So it's this 807 blah 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 thing. So now here's where we reach for the old obj dump. Actually no, here's where we just go into the directory and there's these ASM files. Seven. All right, you know, actually, I think it is obj dump time. Wow, okay. Obj dump. Man, what are the command line arguments for obj dump even? -d fs. Does this do anything? Whew. Okay, so here we're looking at fs. So the reason I thought this would be interesting is because I just want to see what assembly instruction is running that triggers this fault. Here. Okay, so here's the approximate place, but 80751D. Sup, Raj? Contribute to kernel or developing something? Yeah, just kind of working on this kernel. I'll invite you to check out my new welcome page, which has a little bit of context. Because we actually like finished the course, and so I'm not completely working on that course anymore. But Ismail's right. Yeah, that's kind of like the base kernel foundation we are working with. And now I'm just kind of doing fun side projects with this course OS, such as porting to the LLVM toolchain. 80751D. So 80751. I don't know what really is going on here, but like, wait a sec. So this is like the very end of the text segment. Super weird. It says IP 80751D. That's not even a valid IP in our program. Look at all the, so these are all the CC runtime functions. Bro, it's asking for a login. No, you don't need a login. Check it out. You just click you just click these links. There's a lot of links here, so no need to log in. But okay, this is weird. So we're like at the very end of the binary where a lot of these CC runtime functions are. And weirdly, default VA. Okay, I don't know. That's like very strange. Okay. Anyway, back to what we were looking at with the env thing. So what's up with the permissions? So program header has these flags. And flag exec, blah, blah, blah. I think we are completely not using the flags at all. But then how does that? But wait, how does that work? Obviously, we're able to execute code. I guess we don't support the no execute bit at all, I think, yet. So everything is executable technically, I guess. And just simply, I think right now we're just allocating only RWX memory, like always. Which, like, yeah, it's kind of not good to allocate RWX memory always, but it's like kind of simple to do that. And so for that reason, I don't really see how that weird, this weird row data permissions thing would cause an issue. But look at, okay, there's something very interesting about this. Look at these addresses. It's like 80508075114, 8075113. So, and then the crash, where's the, the first crash is at 80751D. So there is something sort of suspicious and slightly sketchy about this whole 807D range. I'm gonna also kill the palm tree because we're kind of getting close to the end of time. Wow. Let's just look at these virtual. This is like kind of interesting. So I'm a little bit surprised at this. Like this whole setup is like a little bit odd actually. I would sort of expect this load segment to be a lot closer to the start of a page, but it's hex 514 bytes into a page, which is very far into a page. So I don't know. I'm wondering if, again, elf loader issues are possible here. I think what I'll do now is just quickly try to resume that original debugging thread with going like into GDB and stuff. Yes, bfs init, continue. Because I think we were kind of getting somewhere. So step, and I will even I guess I can even break on C printf. Hey Anand, no, not a professional kernel developer, just a hobbyist. So now we're, yeah, but maybe someday, I don't know, could be cool. All right, so now we are at C printf, and you know what? Something is that just kind of connected for me. It's a little bit of a theory, but CC runtime is mostly like these functions, these internal compiler functions that are provided by CC runtime. I think most of the code in the OS doesn't really do anything that requires them except for the printf code. So I am a little bit, and also like all this stuff we were seeing here, it's like, this is all in the CC runtime code. And so it would be really unfortunate if this were possibly like a issue with CC runtime somehow. I would be very disappointed if that were the case, but I wonder if so now the question is, what do I, so now how far do we step? Also, so printf.c, what does this look like? VC printf. So we need to step into here. Step into here. Yeah, so step. Wait, where are we? What is this? B.index? Print. Oh, it's libprintf. We're in the wrong in the wrong file. Okay, it's confusing. So now we're here. And v print format, blah blah blah, something something, and then sysc outputs the final buffer. And v printf just like renders into a buffer or something like that. Put dat. Go to number, print num, because this is the boringest format string ever, basically. Also, check this out, device presence 1. So remember, like, we were seeing some very sketchy addresses happening. I guess they're kind of gone now. Like, yeah, these very sketchy addresses with the like EEBF, blah, 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 blah. This is also EEB. This is like kind of close. But let me just walk it back. So here, X, and then X, what? Check for disk 1 to be ready. Also, like this, all this code is only related to managing 2 disks or something. And I guess we do use 2 disks. We have 1 disk. Oh, wait a second, do we? We used to have 2 disks when we were using the custom bootloader. But actually, we don't even do that anymore. Ooh, I wonder if that is connected here somehow. Anyway, device presence X. This is like very hard to understand. I did not write this code. It's something along the lines of if the device is present. VC printf. And so what are the arguments to VC printf again? It just takes two. Okay, so VC_printf takes the format string and then the VA list. Okay, so back to here. So here's like really the core of, yeah, the core of what's going on. But like I was saying, this is pretty much the most boring format string ever. It has a bunch of just normal characters and then the %d. So so this is the signed decimal thing. So that's interesting. Get int. Okay. So it reads an integer. Sysc puts, that's the system call. And yes, that it could also be a problem there too. Well, the reason why I sort of don't think so is because this is the sysc puts is a really light wrapper over some just like kind of pretty just like, it's just code that just like triggers a system call. So not a lot of stuff is happening here. So basically when we hit this function call, we almost immediately leave user space. And from what we see here, the page fault happens in user space. And so there's not a lot of opportunity for something to go wrong once we go into the sysc puts, as far as I can see. And so I'm sort of looking for bigger, juicier user space code that could potentially be triggering this. And my theory so far is that it's in the printf routines. That's like a huge, juicy chunk of user space code that has the potential for triggering the page fault, I think. And so I don't see anything super suspicious here. But what about this number thing? Print num. So basically I sort of have my eye on this division. I think that is where we hit a call to the cc runtime function, one of those division functions. We can even try to check this, and so we can look at print num here, and we can see a call. We can see the call to udiv di3. So that's sort of what I'm talking about. I also had that intuition just because I knew that before, I remember this not linking properly, which was the whole reason why we ran into all these libgcc issues. So I had this suspicion that division is something particularly relevant or tricky. So it looks like there's a couple calls here, but none of them are that close to those weird 8075 addresses that we were seeing earlier. This range was that really suspicious range where it's the end of the text, but somehow the beginning of the read-only data, and somehow we are 1D, just a couple bytes over here, sort of page faulting. Very suspicious. So here's my guess. I'm gonna guess that it's safe to breakpoint at print num. Because we're kind of like breakpointed kind of early in the printf process. I'm going to breakpoint at print num, and I'm going to hit continue. I'm going to hope that we hit it, and we did hit it. So nothing bad happened yet, or did it? I don't know. Nothing bad happened yet, but I think we're close to something bad happening. And what? So where should I step next? If num, let's just print out some of these. Okay, we actually it did that for us. So num1 base 10 with pad C. So nothing special was customized. If num is greater than equal to base. So no, that did not happen. So, but now we hit this part where there's nothing interesting going on. So now I'm not so sure anymore. Now I sort of think we're just going to straight up, like, what's width? Width is -1 also, so this is not really going to do anything. So then we're just going to straight up hit the put char, and maybe the mod? Okay, I don't know, let's check it out. I wonder if the mod could trigger problems. So let's do it next, because we're about to execute this line with the mod, and mod triggers the libgcc thing. And that did it. Wow, look at that. That's crazy. It was the mod. The mod. Should have guessed it. And then things like kind of explode. That's crazy. It was the mod. What the? So in terms of assembly, that's going to be somewhere like here, I think. So now we are really drilling down into it. Like the goal is to really find the specific assembly instruction. And we're getting pretty close, actually. So, yeah, wild stuff. This is fun, though. Kind of like a bit of a investigation, private detective kind of situation. So I'm just going to go like straight, like to the source. I'm going to break directly on this mod function. Which we can see is in CC runtime. And I'm just going to continue and hit enter. But look at that. Actually, we never hit it. So it wasn't really the mod. We never even hit the mod. Ooh, we didn't hit the mod, but what did we do? We hit this line, which is this put char blah 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 put dat. So and put char is a function pointer. Okay, let's just try that again. Going to, where should I break? I guess I'll just break the nefs and it like usual. Step Yeah, it is a little bit annoying. B, C print F, continue. Next step. Okay, so now I'm going to break on print num. We're back here. We're gonna step, we were just here. So now we're at like the juicy point. Put char, blah, 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 blah. And let's disassemble. So here we are. Why is my resolution so bad in Miro? Like, I could have sworn they had better resolution. All right, so here, yeah, like, so this is interesting. We never hit the mod di3 breakpoint previously, so that basically means the problem is in these instructions. Something goes wrong in these instructions. Unless the breakpoint weirdly didn't work. Thank you, Mohammed, appreciate that. Unless the breakpoint somehow did not work, it's gonna fault in one of these. So let's just step instruction by instruction and just check it out. So move EX hex 20, and so it just sort of orients us. So let's just see which one makes things blow up, if any. Maybe it's none of them. Okay, that is interesting. So that, but then we're hitting the mod. I'm gonna step into here. Okay, now we're in some crazy shit right here. Compiler RT ABI. Now that is interesting. What if there is an ABI issue? But also, why did we not hit the breakpoint? Anyway, okay, so weirdly we did not hit the breakpoint earlier, but now we're in the mod. And I'm just going to I'm just stepping like crazy. This is above my pay grade too. I have no idea what I'm doing. Wow, this is like we are like deep. We are like, all right. What do I do now? I think I'm gonna try to like, we're like really deep into like this CC runtime stuff. I'm gonna try to like kind of get back out because I don't really know where I am and how far I'm gonna use the finish command. Try to kind of, run until exit. So that, yeah, so that triggered the issue. Okay, so it's definitely in the CC runtime code, which is really unfortunate. Something is crashing within CC runtime. And mod umod. What's the function? It's like umod di3. I'm like a little bit half not surprised that we're running into this, because I sort of get the sense that the people that make CC runtime are very 64-bit focused, and maybe they just don't care about 32-bit x86. But Ismail, I share your intuition. I thought this was just a standalone copy of LLVM stuff. So there shouldn't be a bug in the functions per se, but yeah, like as Useless is saying, in terms of like the compatibility or the ABI or something like this, calling convention type of deal. Oh, okay, yeah, what to do? I mean, something, it's like compiler flags or linker flags or like something whack like that. If arm eABI, so it's not us. So for us, wait a sec. Yeah, no, this thing is empty. But the cool thing is we can just take a look at like what the assembly is. Push blah 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 blah. I don't really know what I was exactly looking for, but just basically just clarifying that this is 32-bit code. It seems to have a fairly well-formed function prologue, and I don't know, this is like kind of weird. I do not know what that is, but wait, never mind. So yeah, no. It seems to be like a fairly well-behaved, well-formed function call. What could I do to help understand this better? So one thing I want to just be able to do is debug this a little bit more easily. And I mean, I already tried this, but it sort of seemed like that didn't work. Like I tried to break on the symbol name previously and that didn't work. So, but I don't know if breaking directly on the instruction would do. Oh, what the hell? Wait, check that out. That is interesting. Look at that, they're not the same number. The start of the function is at 390. And for some reason, if I type umod di3, which is the name of the function, it breakpoints at 99. What is that? That's like here, which theoretically also should hit the breakpoint. So now let me see if I continue, I expect to we hit the breakpoint, I think, at exactly the right place. If we look at the backtrace, this is exactly the right place. So that is a really nice, just efficient way to kind of get to exactly where we need to break, at least. Now that, so, yeah. And as we saw before, if I try to do a return from this, it's going to hit the issue, I think. Just to demonstrate that, let's do the finish. Because now we are officially but wait, whoa, check that out. That is fascinating. And that's the problem. Look at that. Also, why is the thing it's got a screenshot such bad quality? I want that 4K screenshot. Come on, what do I need to do around here to make it better? Or maybe I'm just zoomed out too far. Or okay. Actually, I should have maybe realized this when we were actually stepping through it. So this instruction is an immediately extremely suspicious instruction, because this is the instruction you get when you just have like all zeros as the instruction. And what this is telling us is that like the program didn't get loaded correctly. If we disassemble at this address, we should see the assembly code of umod di3. And what we are seeing is zeros. So somehow with LLD, we're not loading things correctly. So now here's where it's actually useful that we went to examine the ELF structure of this. So whoa, now the plot gets even thicker. Wait, this is fascinating because or is it never, maybe not, never mind. So I was just looking at this thing. This is the address that's like one past the end of the text section. And so actually, yeah. So something went something is up here, and we have a bunch of zeros. Where this function should be, and let's see. So yeah, all my fault as usual. Some bug in the freaking ELF loader, and I'm wondering if it's this code. that. What the? What? Zero out the rest, the before data. You know what? I think I'm like doing it twice in a weird way. Or zero out the before data, zero out the end data. Okay, wait, so back to this diagram. So remember we had this whole thing. We have like some data that we're trying to copy into memory. We get this big, nice chunk of memory, and we get some information saying, actually, no, the start offset is over here. So we place this in here. And so now it's our responsibility to zero out, well, technically we should maybe zero out this chunk and also this chunk, basically. And that's what I'm trying to do here. Zero out the before data. And we're starting from dest v adder rounded down, which is like that aligned offset. And we're zeroing out the difference between dest v adder and there. So that should be like a very straightforward and simple thing. And now what I'm trying to do is zero out that end part. And so I need to compute two things. Like I compute the start v adder for mem setting, which is dest v adder plus file size, which I think should be correct. Dest v adder, which is right here, plus file size gets us to right here. So that's the start point. And memset size, then it's end pointer minus memset start v adder. So memset start v adder is right here. And then end pointer is what? End pointer is dest v adder rounded down plus mapped len. So that is like the rounded down thing is right here, and then mapped len is the entire thing. So that's why I thought it would be correct. So the end pointer really points to the absolute end of this thing. And then subtract the two. To get this. And the interesting thing is what? Well, first of all, there's actually mem size is equal to file size here. So there shouldn't really be, there's nothing that really needs to be mem set to 0 in this segment. I think, yeah, they're just equal. Very interesting. Well, that's the find. It seems like there's just no code, and that sort of explains that weird address. It's because from all these weird numbers, it seemed like we were sort of like going off the end or something like this. So I'm curious, what does this 1,3 number look like? I'm gonna x32x 8075. Or maybe I'll align it to like 0, 0. So, wow, you can... There's just like a lot of zeros here. And then, like, randomly a bunch of data. Maybe disable the memset one by one to find the bug. Okay, I have something else I want to quickly try. I mean, this is like very odd. So one thing I'm just going to try, I'm going to memset to something different. I'm going to memset it to an hex A, hex capital A. And the theory is that, maybe I am somehow miscomputing this and I'm accidentally overwriting like the functions with 0. So I'm going to choose a different number and then just see if we see a bunch of A's when we try to execute. Okay, then we need to annoyingly get this. Continue, bam. Now we're here, we disass, and it's still zeros. So that's kind of a good sign. Because it means that I didn't necessarily mess that part up and overwrite a bunch of code with zeros, which would be really bad. The question still is, why are there all these zeros here? Disable the memset one by one to find the bug. So I think I just confirmed 8073. I think I just confirmed that the memset is not the issue. You would have bet more on the prologue, not the epilogue memset. Interesting. I would find that very unlikely, but I'm willing to try that. Make clean, make. Okay. So my guess is that we're not going to see a difference. Oh shit, why did I just clean it? Oh, sorry, okay. My guess is we're not going to see a difference with that change. So I put a B there. And I'm just going to continue. Bam. Okay. So, whoa, wait a oh, what? So we hit the breakpoint. I mean, okay, I am very surprised, but you might be right, Michal. Wow. So I can't disass, but I can xi EIP. Holy shit, I think you're right. Now that is so unexpected to me, but you are right. at least, I think so. Does capital B, like what is, how do I, hold up. So I want to dump. Sorry. Wait, what am I doing? I'm trying to just confirm that capital B disassembles to an inc edx. What would be the easiest way to, do I have a RASM2? I do have RASM2. Sick. How do you use this thing again? What do I want to do? I just want to like, how to disass just as a string via RASM2. It's just a command line, I just don't remember. RASM, oh, what? Or no, RASM is an assembler, but wait a sec. But oh, I don't. Okay, anyway. But I mean, it kind of just said it. Hex 42. Wait, so pull out the old man ASCII. B, capital B, hex 42. So Michael is totally right. Huge props to Michael for calling that one out. How? I'm actually flabbergasted that is possible. Because I mean, Bro busted out the retard too. Former guy. Absolutely. I mean, to be honest though, Atari 2 is super unpopular in certain security circles. But yeah, no, when I need to go for that, just quick disassembly tools, RASM 2 just comes to mind. I didn't even know how to use it though. Damn. All right. So Miho, maybe enlighten us. Maybe I'm being really dumb right now, but how is it possible that this memset is dest add or rounded down? Like, this is not. This is not that. Oh, wait a sec. But you know what? I sort of have an idea about this, about why. Wait, so also, what's up, Stefan? Long time no see. Thanks for joining the stream. Hope you're doing well. As usual, I'm in a world of pain that I created for myself. But I actually sort of slightly get what's going on here. So earlier in the stream, I was looking at this number and I was like, why? Like, what is up with this number? Why is it so unaligned and like so far. I actually still have that question because there is just something so strange about this load segment. Because check it out, like the text segment ends at 7513, which is which is technically in this page, right? Like, yeah. But this page should be read-only, but this text is in the page and should be executable. So I don't know if like any of you think think that's normal, but I am really confused. Maybe just to map it out visually. So like we have our first segment, which is the text segment, and it's supposed to end at this 807.513 sort of thing. That's like the last valid address, which means that, so if we look at the offset, it's hex 513 bytes into the page. And so we have, right, yeah. So that's here. And so maybe this is even, I don't know, call it this or something. It's like 513, but hex 513 bytes is like a pretty substantial number of bytes. And so our text like overflows into this other, I will just, I don't know exactly the best way to draw this, but pretend there's another page here, right? So if these are the pages, the text is like kind of going past into this thing. But then we have this other load segment that claims to start exactly like right here and have read-only permissions. And this thing is Rx. But this portion of this thing and this thing are in the same page. Like you can only have one permissions for like this whole block. And it weirdly seems like part of the page has executable code and part of the page has read-only data. Which is super mysterious to me, but that aside, I think if I just comment this out, things might start to work, because what I'm doing with this line is I was taking the virtual address and I was just zeroing out everything in the page that came before it. But I wasn't expecting this to be like such a high offset. And I also wasn't expecting actual data to be overflowed into that region. So what was going on is we loaded this segment, we copied in all this, like this part, this text in there. And then when we're processing the next load segment, I come in, copy in the data here, and then zero out all of this data right here, which includes the end of the text, which is where all our libgcc functions or cc runtime functions live. And maybe that was actually just a straight up inappropriate thing to do. Like, I still don't understand how it makes sense to lay out the load segments like this, because it seems like there's actually a legitimate like conflict, if I'm not missing something. But anyway, for the purposes of just moving forward, let's just give it a run and see if it maybe works better this time. Okay, mkemu. Let's go. No. Okay. That like, I don't know. That makes things worse. How is that possible? All I did was do you think maybe that A is now messing? No. Didn't we confirm that? I mean, we were kind of careful with that A thing, so maybe I will remove. I mean, that A is kind of messed up to do. All right. Oh shit! I gotta go. All right. Make kemu. Nope. Nope. All right. Not happening. It is still kind of crashing, but in a weird way. But that's an interesting find. So unfortunately, I do need to leave. So I got to wrap up the stream, and so I'll do my usual thing. But thanks for hanging out and watching me try to figure out what's going on with this this problem. Here's my Discord if you want to join and hang out. Please subscribe to the channel if you're interested in these topics and want to see more of it. And I guess we'll look into this next week, and hopefully we can dig a bit deeper and actually find the bug. But until then, hope you have a great week, and I'll see you in the next one. Peace. Thanks for hanging out.